Okay, let's jump right into it. Now, we all know summers in India have always been notoriously hot, right? That's a given. But what we're witnessing right now, it's not just a seasonal occurrence anymore. It's fully transformed into a structural, persistent climate crisis. Welcome to This Explainer, where we're going to unpack the really complex web of geographical, meteorological, and human factors that are driving India's 2026 extreme heat emergency.
To really grasp the scale of what we're talking about, I want you to just let this number sink in. 97. Out of the 100 hottest cities in the entire world right now, India is home to 97 of them. It's staggering. This is a massive shift, and it places the subcontinent right at the absolute epicenter of a global climate emergency.
So, to understand how this happened, here's our agenda for today's Explainer. We'll start with the global heat capital, move into the anatomy of a perfect storm, look at the urban heat island effect, discuss the human cost, and finally wrap up with forecasting and adaptation.
All right, kicking things off with Section 1, the global heat capital. What used to be just a hurdle, those few tough weeks you'd sweat through right before the monsoon, has basically become a year-round emergency. And the footprint of this heat is expanding incredibly fast. Case in point, power demand in India just surged to an all-time record of 270.82 gigawatts. That is mind-bending. Air conditioners and cooling systems are quite literally running nonstop just to keep things functioning, which is putting immense stress on power grids and seriously accelerating water shortages across the region.
So, structurally, what's happening? Well, to understand this extreme weather, you have to picture a massive, invisible lid being placed directly over the country. Scientists call this a heat dome. It's a high-pressure system that traps hot air, squashes it down toward the surface, and heats it up even further. And because this dome just sits there, completely stationary, it physically blocks cooler winds, cloud formations, and any of that pre-monsoon relief from rolling in. Basically, the furnace is left on, and the door is shut tight.
Which leads us to our next part, Section 2, Anatomy of a Perfect Storm.
You see, this emergency goes way beyond a blanket term like global warming. It's a precise, brutal collision of three converging drivers. First up is geography. India is highly tropical, and the massive Himalayan mountain range to the north essentially traps all that hot air in. Second, we've got climate cycles. We're looking at a developing super El Niño in the Pacific, which is pushing sea surface temperatures up by about 2 degrees Celsius, acting as a huge risk multiplier. And third, human activity. The rapid, endless sprawl of concrete development and greenhouse gas emissions.
Now you might be thinking, wait, why is India suffering even more than some literal desert regions? Well, think about a desert. It cools down really quickly at night, right? Because sand doesn't retain heat very well. But northern India's sprawling concrete cities act like giant thermal batteries. They soak up the sun all day and then radiate that heat back out all night long. Couple that with the fact that we're missing those expected Mediterranean weather systems, those western disturbances, and the Indo-Gangetic plains are just left continuously baking with absolutely zero nighttime relief.
And this isn't just theoretical. Look at the mapped data coming from the meteorological department. You can literally see these distinct hotspot regions. Notice the deep red areas highlighting north-central India and the southeast coast. It's intensely tracked science. Now, north-central India sees these massive, towering temperature spikes, but it's actually the southeast coast that frequently experiences higher mortality rates. We'll get into exactly why that happens in just a second.
But first, let's zoom in on the cities themselves. Section 3, the urban heat island.
Take Delhi, for example. In just 2 decades, 20 years, Delhi's green cover plummeted from 82% down to 62%. Trees and lakes provide crucial natural cooling. But when you pave over them with low-albedo concrete and dark asphalt, you create these localized pockets of extreme heat. Without realizing it, we're essentially building habitats that are perfectly designed to cook their inhabitants.
And that brings us to the most critical part of this explainer. Section 4, the human cost. We absolutely have to talk about wet bulb temperature, because frankly, this is the true killer. Wet bulb doesn't just measure heat, it measures heat combined with humidity. Now, your body cools itself by sweating, right? The sweat evaporates, pulling heat away from your skin. But if the humidity in the air is too high, your sweat literally cannot evaporate. At that point, a temperature of 38 degrees Celsius at 80% humidity can actually feel like a deadly 48 degrees. Your body physically fails to cool down. In those specific conditions, the heat becomes completely non-survivable, even if you are sitting perfectly still in the shade drinking water.
Mariam Zakaria over at Imperial College London summed it up perfectly. She said, "What used to be rare heat in South Asia is now a regular reality. Because of human-induced climate change, these deadly 15-day pre-monsoon heat waves are now roughly 3 times more likely than they were in a pre-industrial climate. So what used to be a once-in-a-lifetime freak anomaly, it's now happening every few years."
And if we look at the timeline, it's clear the transition seasons are just shrinking. The whole concept of spring is practically disappearing. We're seeing life-threatening heat arriving as early as late February, pushing near 40 degrees. It's staying longer through May, triggering hundreds of suspected heat illness cases and tragic fatalities, especially among outdoor workers. And the really scary part? As we look ahead to the winter of 2026, the peak impacts of that predicted Super El Niño are still looming on the horizon.
So what are we actually doing about this? Let's move to Section 5, Forecasting and Adaptation.
The good news is researchers are fighting back. At IIT Delhi, they've developed these incredibly sophisticated methodologies. They're going way beyond just reading a thermometer. They combine physical exposure, things like land surface temperature and population density, with what they call adaptive capacity. A huge factor there is a neighborhood's average income level. Why? Because if you don't have the wealth to buy and run an air conditioner, your vulnerability skyrockets. Using this data framework, they can map out exactly which specific city wards need immediate life-saving intervention.
And on a national level, the India Meteorological Department has a highly structured playbook. They are actively monitoring dangerous wet bulb temperatures in real time using web GIS systems. From there, they issue these localized, 5-day, color-coded forecasts. When those red and orange alerts go out, local health departments know exactly when to trigger their heat action plans. And these plans are comprehensive. They dictate everything from shifting school hours to mandating strict hydration breaks for outdoor workers across 23 highly prone states.
So bringing it all together, the data is just undeniably clear. Extreme heat is no longer an anomaly for India. It is the baseline. As those deadly wet bulb temperatures keep rising and the concrete sprawl expands, managing this crisis is going to require a lot more than just plugging in more air conditioners. It demands urgent urban redesign, flawlessly executed early warning systems, and, frankly, a massive global commitment to emissions reduction. So I leave you with this question. As the furnace remains on, can our cities, our hospitals, and our infrastructure survive the new normal? How we choose to adapt right now will literally define the survivability of our